Hi everyone, welcome back to the OceanBase YouTube channel. I'm Annie from the OceanBase Global team. In this video, I'll walk you through how to integrate OceanBase with LlamaIndex to build a document queue and a system powered by AI using our built-in vector search capabilities. Whether you're just getting started with RAG, Retrieval-Augmented Generation, or you're exploring how to combine databases with LLMs, this tutorial will give you a hands-on example using open tools and real data. Let's start with a quick recap. Since version 4.3.3, OceanBase supports native vector data types, vector indexing, and high-performance vector search, all built directly into the distributed SQL engine. This means you can now store your embedding vectors directly in OceanBase and perform semantic search using SQL or modern AI frameworks. But here's the question: how do you turn these capabilities into a real AI application like Document Queue and A or RAG? That's where LlamaIndex comes in. So, what exactly is LlamaIndex? LlamaIndex is an orchestration framework that helps you connect your private data like documents, databases, or APIs with large language models like Qwen or ChatGPT. It provides a full set of tools for ingesting, indexing, and querying your data, making it much easier to build AI applications like Document Queue and A, knowledge agents, or semantic search. You can pull data from almost anywhere: PDFs, SQL databases, websites, even plain text files. Then, LlamaIndex lets you index this data in multiple ways, from simple lists to binary trees to vector stores, depending on your use case. In our case, we'll be using the Vector Store Index, which stores your data as embeddings inside OceanBase, perfect for similarity search. Finally, LlamaIndex gives you a natural language interface to query your data. Just type a question, and it takes care of the rest using prompt engineering behind the scenes. Now let's see how we can actually put this all together, with OceanBase handling vector storage and search, and LlamaIndex orchestrating the data flow and queries. To follow along with this tutorial, here's what you'll need. First, OceanBase version 4.3.3 or above, with a MySQL tenant already set up. Second, Python 3.9 or higher installed in your environment. Third, an API key for Qwen, which we'll use for embeddings and LLM responses. And finally, you'll need to install a few Python packages to get things working. Also, make sure your OceanBase system has the vector memory setting configured. You'll need to set OB vector memory limit percentage to 30. This enables vector indexing and retrieval. This setting controls how much memory is allocated for vector operations. Without it, vector search won't work properly. Alright, let's get everything ready and jump right in. You'll need to get your OceanBase connection string. This could be through ODP or a direct observer connection. The user must have create, insert, drop, and select privileges. We'll start by setting up the API key for Qwen, which we'll use as the LLM backend to generate answers. This key allows LlamaIndex to send queries to Qwen and get responses in natural language. Next, let's download a sample document that we'll use for testing our Q and A system. Now we'll load the sample document and build a vector index. This lets us perform semantic search over the content. Now that the index is ready, we can query the document and see how the system responds with AI-generated answers. And here's the response from the model retrieved from OceanBase using vector similarity search. Pretty cool, right? You've now seen how to connect OceanBase with LlamaIndex and build an end-to-end semantic document Q and A system. Please refer to the video description for links to the code and documentation. If you found this helpful, don't forget to like, subscribe, and check out our other videos on OceanBase plus AI. See you next time.